So today we're going to look at a few examples of word problems that require us to draw the picture and then figure out what's going on. So the first one is already drawn for us, but I want to go through how we drew that. So in example one, we have here, and guys, please remember, you should be writing these examples down. Even if you're just quickly doing like a summary of the problem, then redrawing the picture and doing the work with it, that's going to be very, very helpful here. So a boy is flying a kite and lets out 300 feet of string, which makes a 38-degree angle with the ground. Assuming the string is straight, how high above the ground is the kite? So right away, I'm actually going to draw over the picture we have to just kind of re-explain the idea of turning the words into our visual representation so we can do our trigonometry here. So a boy's flying a kite. So right away, we do the little, just put in this little stick figure here for the guy. And then we let it out and the kite is way up here. Gave a little string to the kite and everything. Now, it said they let out 300 feet of string. So the 300 feet of string, we're getting that right here. So that is how much string was let out. Again, you're going to look at the context of the problem to figure out where these numbers go. And we know made a 38-degree angle with the ground. So with 38 degrees, the ground is down here. And I know the angle it makes is 38 degrees. Now I want to know how high above the ground this is. So what we realize is if we come straight down, that makes a right angle. And then this is my unknown side, x. So what do we need? We need the height above the ground. Okay, so now what we're going to do is we're going to take the information we had yesterday and work it from there. So when I look at this side across from the 38, that's my opposite. This side that's 300, that is my hypotenuse. And that means the ground is the adjacent side. So now all we're going to do is work it like we worked problems from yesterday. So right away, I notice opposite and hypotenuse is where I have information. So since I have opposite and hypotenuse, that tells me, oh, SOHCAHTOA, sine is opposite over hypotenuse. So that's what I'm going to do. I'm going to say the sine of 38 is equal to my opposite, x, over my hypotenuse of 300. Now it's just a matter of solving for x. When we open the Desmos calculator, we must remember to go from radians to degrees. Otherwise, things are going to get ugly for us. It's not going to give us correct answers, and that's going to be an issue. So we just need to make sure we do that little swap. Remember, I'll go over that again. Only takes us about 2 seconds to fix it, but we need to make sure we do that. So here with this, I'm just going to multiply both sides by 300. and we get 300 times the sine of 38 degrees is equal to x. That's how high above the ground this kite will be. So let's open up Desmos, graphing calculator. So remember, we had to go to that upper right-hand corner where the wrench is to change our settings. Right now it's in radians. We need to flip it over to degrees. We've done that. Now we should be good. I'm just going to type it in. 300 times the sine of 38. And that gives me 184.7 feet. So when I look at this, if we think about this for a second, if I'm flying a kite and I let out 300 feet of string, that's like a football field's worth of string. Then it's telling me I'm flying the kite is over 180 feet in the air. That seems to make sense. That seems to work out pretty well, right? Like if I let out a football field's worth of string, that kite could get up there pretty high. So that seems to make sense to me. So again, I will use some real life context clues to help me out here. So here with this, that tells me my answer is X is 48.70. And so how high is it above the ground? Kite is 184.7 feet above the ground. So that is our first example. Do have somebody else coming in. Please make sure you're getting that down. I'll give you an additional 2 minutes to get that down. And if you have questions, please make sure you are asking me those questions.
How do you know to like to write sin or ting? Like how do you know what to write?
Okay, so I'll go over that again in 1 second. Let me just fix up this student that came in, their attendance. And yeah, it's a great question. So how do we go over whether it's sin, tan, or cosine? Great question. So right away, I look back at the triangle here. I have no information on adjacent. I have an unknown on or opposite, and I know the hypotenuse. So I go back to this very first piece of information. Since we have opposite and hypotenuse, that tells me to use sine. If I have adjacent and hypotenuse, I use cosine. And if I have opposite and adjacent with information, I use tangent. So we're always referring back to this with SOHCAHTOA. So it's all based on what information we have and we're looking for. So opposite hypotenuse, that's sine. Adjacent hypotenuse, that's cosine. Opposite and, oh my gosh, sorry about that. Opposite and adjacent will be tangent. I got a little tongue-tied there. Any other questions? That was a great question, and we'll go over that again with the next 2 examples as well. That's my timer going off, not hearing or seeing any other questions. Let's take a look at the next example. Okay, guys, read that while I get this student's attendance fixed up very quickly. So they just got here. There we go. Good. So a ladder is leaning against a wall and makes a 74-degree angle with the ground. If the foot of the ladder is 6.5 feet from the wall, how high up the wall is the ladder? Okay, so I'm going to start drawing a picture here. So I have the ground and I have some wall here, right? I'm going to lean a ladder against it. So that's going to look something like this. So I'm just going to have this look like a ladder. So far, so good on my picture. So all I do is draw out this scenario. Haven't put any information in yet. Now that we have the picture, let's start rereading the problem. We know the ladder leaning against the wall makes a 74-degree angle with the ground. So making a 74-degree angle with the ground, that's this angle right here is 74 degrees. Okay? If the foot of the ladder is 6.5 feet from the wall, that will be across the ground. So that's down here. This is 6.5. I'm pulling that from here. So it's 6.5 feet from the wall. I want to know how high on the wall the ladder is. So what I'm curious about is this height X, right? So what do we need? We need how high the ladder is. So how high the ladder reaches. So with this, I look here, my right angle is at the ground and the wall, so that will help me with the hypotenuse, but right away I know I have opposite over here. Since my right angle would be here, that makes the ladder itself the hypotenuse. And then I would realize that the ground is the adjacent side. Now, a lot of times with these real world problems, the ground, if we're dealing with something talking about the ground will be adjacent to us. That's a sign next to us. And then if we're looking at like a wall or something like that, that tends to be more where we see the opposite side. So now getting back to the question that came up earlier, how do I know which function to use? That is always a great question. So right away, I see I have info at adjacent and info at opposite. So opposite and adjacent. If we refer back to here, opposite and adjacent will be tangent. So we're always coming back to this. Hey, tangents, opposite and adjacent, that has the two pieces of information I have, so we're good for there. We don't like cosine because that's adjacent and hypotenuse. Sine is opposite and hypotenuse. Hypotenuse isn't what we want in this, so I'm not going to worry about that. So here with this, I don't need to switch windows, I just need to switch slide. So this gives us, the tangent of 74 is equal to, now my opposite, that's x, over my adjacent, which is 6.5. Okay? All I have to do now is multiply by what's on the bottom. Multiply by 6.5. So we get x is equal to the 6.5 times the tangent of 74. This should work out to be pretty good for us here. So 6.5 times the tangent of 74. And I get 22.67 feet. Now, if I'm putting a ladder against a wall and it reaches up over 20 feet, that seems like a pretty practical use for a ladder, right? So again, I'm using this real world context. Say, yeah, that's reasonable. If I put a ladder against the wall and I had a height of 7 feet, are we really going to be using a ladder if it's only going up 7 feet? Not really. That seems silly. But if the ladder's going up 22 feet, yeah, that seems like a time you would definitely be using a ladder. So again, my answer seems reasonable in a real world context. So again, we get x equals 22.67 feet. So how high on the ladder is how high on the wall is the ladder? The ladder reaches a height of 22.67 feet. Again, real world context tells me that makes some good sense there. Any questions on this? Again, I'm going to set a 2-minute timer for you to make sure you got this not only done or copied down, but give you a second to think about questions if you have them. That student was. Let me double check I got their attendance. Okay, I did. Cool. Must have just been like a blip on their service. That's fine. Again, any questions? You can unmute yourself or use the chat while you're getting this down.
Isaac,
Yeah.
what time is practice to?
Practice is regular time, so hopefully try and get to here by 2:30. Give me about another 30 seconds, and we're going to look at our third word problem. Now I'm just giving you the rest of class to make sure you got yesterday's work done, and you start these word problems, which you will have time to work on tomorrow as well. I know these word problems are going to be a little tricky, and we might need a little more help and support with them, and that's not a big deal at all. There we go. There's that timer. So we've got one more example here. So here now, that person in. So a straight road to the top of the hill is 2,500 500 feet. Second, sorry about that. And makes a 12-degree angle with the horizontal. We want to find out how tall this hill is. Okay. So you have some road that's going up like so. I'm going to put a little car here just to help us see that it is a hill. So you'll see that I like to add a little bit of my very mediocre at best art into these just to help bring the context to it. It's not just a triangle I'm drawing. I'm thinking about what's actually happening here. So I'm told that, like, if the ground was flat, it'd be like this, right? So that's why I'm putting this dashed line here to represent the ground. And I can put a dashed line here to represent the height. So the height and the ground will meet at a right angle. Before I start putting information in here, is there any question about just a general picture I made of, hey, this straight road goes to the top of this hill?
Isaac,
Yeah.
you know how it says 12 degrees?
Yep.
How do you know to write it on the like left side or the like right side of the angle? Like, how do
Great
you-
question. Let's go ahead and add that in now. So it makes a 12 degrees with the horizontal. So that tells us right there, it makes like a 12-degree angle, like it's going up at 12 degrees. So I know that's making that with the ground. Most times, unless it's a scenario where we're looking downwards, we're going to be making an angle with the ground in these scenarios. So I don't want to say, oh, every work problem is at the ground, but in a lot of them they do. So a lot of times it will be this angle that seems to be meeting up with the ground. Great question. Okay, let's see what other information we have. We know that the road is 2,500 feet long. So just to give you some context, let me quickly get a conversion there, just so we have a little more of an idea of how long this road is. So this road is about a half-mile stretch up a hill. So for half a mile, we're driving uphill. Just keep that in mind for the context of how tall this hill is. Now we want the height of the hill. So the height will be over here. That's X, that's our unknown. So we want to know the height of the hill. I misspelled the word height. Sorry about that. Height of the hill. So let's see here. 12's here. This X is all the way on the opposite side. So that's my opposite. My right angle is the ground and the height meeting. So that puts my hypotenuse at 2,500 feet. And that would make the ground, if everything was flat, my adjacent side. So right away, again, I'm looking. I have info at hypotenuse. I have info at opposite. So, oh, opposite of hypotenuse, opposite of hypotenuse. Oh, that's sine. So I'm going to have to use that sine function again. So I'm going to now say the sine of 12 degrees is equal to my opposite x over my hypotenuse of 2,500. So now I'm just going to multiply both sides by 2,500. Those cancel out. X equals 2,500 times the sine of 12. That we are definitely going to have to use a calculator for, so let's go ahead and do that. So 2,500 times the sine of 12. And we get that this hill is nearly 520 feet tall. Well, if I'm thinking about that, okay, if I'm driving up a hill for nearly half a mile, I'm going to get some real height there. So to be like 500 feet above the ground, yeah, if I'm going up for half a mile, that doesn't sound too unreasonable. So I'm going to say, yeah, that sounds pretty good. So what was it more precisely? So that would be 519.78 feet. So that's x equals 519.78. So the hill is 519.78 feet tall. And that's it. Any other last second questions you guys have for me? Not hearing any questions coming up, and that's okay. We do have these word problems to work on. I'm not saying they're the easiest thing in the world, but hopefully we have some idea of how to handle them. So again, if we go in to our folder, everything is fixed up from yesterday. So if we go into our work for Wednesday and major activities, you see the blank notes. I'll put the completed up in a little bit along with the work. So the work, just a PDF with a few of these different word problems. So we got 9 word problems to try. I need you just to give your best on them. If you have questions, need help with them, I'm right here to support you. So we have about 25 minutes to get started. So we'll stop the recording so we can have that for later. Yes.